AP Statistics 1.2 Part 2. Hey class, Mr. Shu here. I'm going to try to sound less monotone today, but we are going to be going over the topic of histograms. So why don't we go ahead and get started. So, today we're going to be talking about histograms, okay? Yesterday we went over dot plots and stem plots, and those are two common ways of displaying quantitative data. Now, the third way of displaying quantitative data is histograms. Histograms are probably the most common way of displaying quantitative data. Okay? So, what is a histogram? You've probably seen it before, and up to this point, you probably called what is a histogram a bar graph. Okay? And I'm going to tell you why why you think that is, okay? Because when you make a histogram, the first thing you do is you divide whatever data you have into separate small ranges, okay? So you kind of like divide the quantitative data into classes with equal width, okay? And we're going to talk about what that means in a minute. And then you count or you find the frequency or relative frequency, in other words, count or percent, that lie within each range of the data. Then you label and scale your axis, your X and your Y, and then you draw your histogram using bars of equal heights to the frequencies that you counted. Okay, so you might be like, Mr. Shu, what the heck did you just say? I'm going to make it easier for you. So, this is in your book. You can take a look at page 35 if you would like on the book scan. But what this data is this data tells us what percentage of residents for each state were born outside of the U.S. So in other words, permanent residents, right? Like if they have, if they live in a certain state, but they were born outside of the U.S. So like my parents, right, would be counted in this. So there are a total of 50 states, right? What this means is that they divided their ranges into ranges of 5%. So states that have 0 to 5% immigrants, right? Or 5 to 10% immigrants, 10 to 15% immigrants, so on and so forth, right? So what this represents is that there are 20 states that have between 0 and 5% immigrants. There are 13 states that have between 5 and 10% immigrants. And there are 9 states that have 10 to 15% immigrants. I believe Illinois is here, okay? And then 15 to 20% there are 5 states. 20 to 25, there are 2 states. And 25 to 30% immigrants, there's 1 state. I believe this state, based on my memory, is California, okay? So, as you can see, first we scale and label the axis. Now, you'll notice the y-axis, they labeled as number of states, because we're counting the number of states, right? Okay? And then the ranges is for 0 to 5%, right? Foreign-born residents, right? So 0 to 5, 5 to 10, 10 to 15, 15 to 20, 20 to 25, 25 to 30, right? Okay? All right, so then we put our bars. There are 20 states that are between 0 and 5%, 13 states that are between 5 and 10%, so on and so forth, right? Now you might be like, Mr. Shu, how is this different from a bar graph? And the answer is, it's because a bar graph displays the counts of a categorical variable. You see, this is quantitative. These ranges have a quantity, okay? And when the ranges have a quantity, then it is called a histogram. If I were to change this to like favorite colors, right? It wouldn't matter what order I put it in because there's no quantitative value. That is a bar graph. If I do have a quantitative value, however, I can't just take this 0 to 5 range and put it over here. Okay? If you want me to explain more, I can and I will during our time together. Okay? All right. So, number one, we just went over. Don't confuse histograms with bar graphs. These are two different things. Okay? Says don't use counts in a frequency table or percents in a relative frequency table as data. Okay? Oh, I see. These are probably more for bar graphs and pie charts. Let me check on that. Use the percent instead of counts on the vertical axis when comparing distributions with different numbers of observations. Okay, yep, that's true. Because if you have different sets of data with different sets of data with different numbers of people that were surveyed, then you want to count on the percent versus the actual number, because it's, if you compare the actual numbers, you might get confused, okay? Just because a graph looks nice doesn't mean it's necessarily a meaningful display of data. We went over this at the beginning of yesterday. We had a really nice looking graph which didn't have much meaning, okay? If you want me to go over examples of it, I can go over it during our time together. I believe that is it for today. Peace.